So, hello everyone. Today we're going to solve this problem, number of ways to arrive at destination. So, the question is, you are in a city that consists of n intersections numbered from 0 to n minus 1 with bidirectional roads between some intersections. The inputs are generated such that you can reach an intersection from any other two intersections, that there is at most one road between any two intersections. You are given an integer n and 2D integer array roads where roads I equal to u, v and time. Means that there's a road between intersection u and v that takes time I minutes to travel. Okay, so you want to know in how many ways you can travel from intersection 0 to intersection n minus 1 in the shortest amount of time. Return the number of ways you can arrive at your destination with shortest amount of time. So, what the question is saying, let me just take here an example. This is an graph which we are given. We have to tell from node 0 to node n minus 1, which here is 6. What are the possible number of ways we can go at minimum time? So if we check, if we go through 0 to 1, then 2, then 5, then 6, we can see the time is 1 plus 1 2 plus 3 5 plus 2 7. Similarly, if we go to 1, then 3, then 5, then 6, the time you can see is 1 plus 1 plus 3 plus 2 again, that is 7. The another way is from by 1 to 3, then to 6. But the time here is 3 plus 3, 6 plus 2, 8. So what we are needed to give is the minimum distance. So since we already got 7, 8, we can consider 8 as it's greater than 7. So we'll not consider that path. So the next path would be from 0 to 6 directly, that is 7, 2. And the next path will be via 4, that is 5 plus 2, 7. So here we can see that there are total 4 number of ways by which we can go from 0 to n minus 1. So how can we do this? So to solve this question, first you have to think that what are the number of ways we can get to each and every node. For example, we're starting from 0. So the number of ways to reach 0 is always going to be 1, because as we're starting from it, there's no other way we can go to 0 until and unless we come back again. But since, okay, so restart. So, so to solve this, we have the approach is to know how many ways are there to reach each and every node. Since we're starting from 0, the total number of ways to reach 0 is going to be 1 only, as we're starting from it. Then we can see the number of ways to reach 1. We can see there's no other way to reach 1 other than 0. So we can say the number of ways to reach 1 is 1. Next, 2. Since there's only one way, we'll again mark it as 1. If we see 3, there is only one way to reach 3 via 1. So again 1. Now 4 is also going to be 1. Similarly, now this you have to see. The number of ways to reach 5. How many are there? First way is we can go via 2, and the other is we can go via 3. So you can see here are total 2 number of ways that we can reach 5. So this is the thing you have to keep in mind. So the number of ways to reach 6. Similarly, since we are getting from 0, 4, 3 and 5, what we'll do is simply sum up all those particular ways. The node we're reaching, we have to add these number of ways we're reaching those particular nodes. So here we have to sum 2, 1 plus 1 plus 1. So that is going to be 5. But the another point is we have to tell only the minimum path. So how do we know that minimum path? Dijkstra algorithm. Dijkstra. So the minimum path will get through Dijkstra and the number of ways will get through by counting each and every node. The moment we reach that node, we have to count that number of way to it. So since wire 3 is greater, as we saw, 2 plus 3 plus 3, so we'll only consider from 5, from 0 and from 4. That is 1 plus 1 plus 2, 4. So let me tell you the dry run of this code, then you'll understand it better. So as you can see here, what I've done is I've made a ways array to store the number of ways we can reach to each and every node, and a priority queue. Since it's Dijkstra algorithm question, so we need to check the minimum path from 0 to 6. So that's why we are doing the Dijkstra algorithm here. So initially we'll start with 0 comma 0, as we will be starting from 0 and the time to reach 0 is going to be 0 since we're starting from it. So after taking out from the priority queue, we'll update the number of ways to reach it. So since the 0 is the first one, we'll update it as 1, since there's only one way to reach 0 as we're starting from it. So from 0 we're reaching to 1, we'll simply update it. Since we know that in Dijkstra algorithm all the initial distances to each and every node is infinite, so if the distance is shorter, then only we'll update and put it to priority queue. And if the distance is shorter, then only we'll update this ways. So since you can see here, the distance to reach 1 is going to be 2, that is shorter. So we'll simply push it here and update the number of ways to reach 1 as 1. Why 1? Because the number of ways to reach its parent was 1, so we'll simply add it to the already existing number of ways, which was 0. So 0 plus 1 is going to be 1. Then the second node we're reaching is 6. So since uh, it's the minimum way to reach 6, we'll simply push it here as 7 6 and update it as 1. Similarly with 4, the distance is going to be 5 and number of ways to reach is going to be 1. Now priority queue will take out 2 comma 1 since it's min heap and update it. So after from 1 where we can go is 2 and 3. So first I'll update 2 to reach value 2. Let me just, okay, so never mind. So to reach 2, the distance is going to be 5. Since we're reaching 2 for the first time, obviously the distance is minimum. So what we'll do is simply add it to the priority queue and update its number of ways. Then again to 3. Similarly, we're going to update to the push it to the queue and update its value. Now the minimum is going to be 5 comma 2, so we'll take that out. And where are we reaching from 2? 5. Okay, So 5 till now was unreachable, so let me just make some space here. I'll push 3 plus 2 5 plus 1 6 comma 5 here and update the number of ways to reach 5 as 1. Now what one is the smallest? 5 comma 3. So we'll take 5 comma 3. Where are we going? From 3 we can reach 5. Now you see, since the number of ways to reach 3 was 1, as you can see here, and the number of ways to reach 5 is also 1, what we'll do is update its value and add this value to it. So the value of 3 will be added to that of 5. So it's going to become 2 now. And we'll simply push this value, push this node again. Now we don't need to push that again since it's already existing, as you know, the Dijkstra algorithm. Now, which one is the smallest? 5 comma 4. So we'll go to 5 4 and the value is going to be, we're reaching 6. So the distance is 7, which is the already existing, I mean the minimum path to reach 6. So we'll not push it here, but we'll update the value of 6 with the number of ways to reach 4. That was 1. So 1 plus 1 is going to be 2 again. Now the minimum is 6 comma 5. So we'll take that out. And now we know that 5 is reaching to 6 with time 1. So the new time is going to be 7 comma 6, since 7 is the minimum path. So we'll simply not push it to the queue but update its time. So what are the number of ways? What I've told you, will add the number of ways to reach 5 to the number of ways we were reaching 6. So these two values will get added and the 2 will get updated to 4. So this is going to be our approach to solve this problem. So moving on to the code. So now the code. First I'll simply make the adjacent vector, that is vector. So now you see I've made the adjacent vector, and other thing which I'll make is the time vector. Since we know that it's going to be a very big answer, so I'm taking long here, and I'll simply make the time vector of size n and store the maximum time. Since it's a long, we can take is 29, 118, and we'll mark the initial time as 0. Now we'll make a priority queue, the min heap, cut स्टोर करेंगे. So priority queue is done. Now what we'll do is make the ways array. let me just make it ways int ways of size n. And initially what I told you that we're going to store here. So initially we're going to store the ways vector as 0 0 0. So I'll just make it that, and the initial would be 1. I'll then simply push the first node to the priority queue and then make a loop around it. Q dot empty, and now we'll just take those values out of the priority queue. That is the time, dq dot top dot first. This will be my node. Then I'll simply pop the node, and for each and every connected node adjacent of node, we'll check its time. So adjacent time, we can say, is going to be it dot second, not first. Then it dot first, it's going to be adjacent node. So when were we updating our ways? So if the adjacent time plus the time is less than or equal to the time of that adjacent node, then only move forward. And if this value, adjacent time plus time, is equal to time of adjacent node, which means if it is the shortest path, the minimum one, we'll simply add it. Ways of adjacent node is going to be ways of adjacent node plus ways of the node. Okay, and if it's not same, we'll update the ways of adjacent node to ways of node. Since it was 0, we'll simply push it. We can do plus, but that means the same. So time will also update the time of adjacent node to that minimum time we've reached, and simply push these values, the time and the adjacent node. So at last, what we need to return is the number of ways at n minus 1th position. So we'll simply return ways at n minus 1. Since we have to return the modulus value, what I'll do is I'll simply make a constant integer mod as this 29, and where was that? Yeah, so here I'll up mod it each and every time. It's strong here. Okay, so the problem was naming conflict, and the data type I would had mentioned was integer, but we're taking it longer, so that was just the issue. So as you can see, the problem is accepted and correct. So that was it. Thank you.